All right, good morning, everybody. Welcome. Welcome, everyone, to the third annual Interstellar Probe Workshop. We are very grateful that you've carved out time from your work, from your home, to be with us this week. Everybody's carrying different burdens right now, and the fact that you have made time to be with us is, we're very grateful for that. On behalf of the entire Interstellar Probe team, thank you for being here. This is the third Interstellar Probe Workshop. And to see the number of people who have signed up, expressed interest, grow from the 80 folks who have joined us in the last 2 years to the 290 people that registered for this conference this week is really, really fantastic. And I'd like to, for those of you who've joined us already, I'd like to give you a minute to greet each other. We're using a Zoom webinar tool right now, which means that the participants are able to ask questions via the Q&A tool. So at the bottom of your screen, you should be able to see a Q&A button. And you can chat with us, the panelists, and I'll introduce the folks who are joining who are on the panel side in a minute. But before I do that, all of you participants are able to enter anything you want into the Q&A section, including hello from yourself. You can each say hello, and I'd like you to do that. I'd like you to chime in on the Q&A section. If you go to that, instead of typing a question, just say greetings from Michael in Pennsylvania, which is where I am. And strangely, the panelists can't actually type questions, so I can't begin that. So I'm going to pick on somebody. Oh, there it goes. Excellent. Say hello, everybody. Say hello to each other. I know that we have folks from the West Coast, from the East Coast. People, I see greetings from Bern, from Andre. Thank you, Andre. Greetings to Alan. Very good. Q&A is for asking questions. And chat, you can chat with the participants, but with the panelists. You can send a chat as a participant. You can send a chat to the panelists. But the chat, I don't believe, is viewable by, oh no, you can do a chat to all panelists and attendees, but I'm a panelist, so I'm not sure if the attendees can also chat to everybody.
Attendees
but everybody
cannot,
can see
they can only chat.
Very good. Thank you, Andrea. The first, so this is excellent. Good morning, everybody. Minnesota, I've got a Go Interstellar from Richard Henry. Excellent. This has been a very exciting project for me to be a part of. The study itself is just a wonder of engineering and science, and the work that the team is doing and is going to share with you this week is just really exciting to me. But the best part of this has been the people that I've met along the way, and it's good to see all of you here with us. Good morning, Jeff Landis. Haven't seen you in a long time. This is great. And we will meet again in the future. We will have our next Interstellar Probe workshop next fall, and handshakes and hellos and coffee and drinks all around will be a great thing. Before we introduce the rest of the team, Andrea, could you bring your video up? Everybody, this is Andrea Harmon. She has been a wonder of logistics and planning. You've gotten lots of messages from her. The whole agenda and plan for this week, she's done a fantastic job of putting this together for us. We're very grateful to her for her work. Very diligent, very thorough, and things are looking great so far. And just really, really excited about the week. Thank you, Andrea. And Alice and Ralph, Jim, and Pontus, if you guys could bring your screens up so I can introduce you all. Just real quickly, Alice ran, for those of you who are not students, and Alice, how many students do we have on the webinar this morning to get started?
I want to say maybe like 50, but
50.
I was too busy running and not enough busy counting.
We had we really branched out this year and invited many students to participate in this. Whether it was going to be virtual or not, this was the plan, and it was great to see so many taking part this morning from 9 o'clock to 10 o'clock. They got their own special introduction to just what this is all about and the role that they can play as the project goes forward. This was really great. Alice, thank you for running that. Jim Kinnison is our systems engineer. Jim is not just the systems engineer for this study. He was the mission systems engineer for Parker Solar Probe on launch day. Jim has been through this sort of exercise before, and it's really excellent to have brought him on to the team last year. I think practically his first day on the job was at the workshop last year. And since then, he has shepherded the engineering team into a place where the solution space for this mission is starting to look very strong and very healthy. Pontus Brandt, our lead scientist, our principal scientist, project scientist, excuse me. Pontus has been working diligently with the scientists, not just at APL, but out in the community, to really strengthen and frame the science questions that this study is tackling for Interstellar Probe, and to turn that into what I think of as an abstracted notional instrument suite, a possible instrument suite, so that the engineering team can go off and do its work. And finally, after I'm done with my opening remarks here, you'll hear from Ralph McNutt, our principal investigator. Ralph, who has really just been a driving force behind this for many years. His NIAC grant from 2009, I believe it was one of the different iterations of this, and he'll be coming up after me, and all of this is driven by his energy and gotten us to where we are. But it's not just driven by his energy; it's also driven by our sponsor. I want to say thank you very much to our sponsor, NASA. The NASA Science Mission Directorate, Heliophysics Division, has funded this study, and we continue to be able to do the work that we're doing because of them. And so, what you're going to see this week is a number of things, one of which is the engineering study results that I mentioned. You're going to hear not just about the mission space that we're studying, but you're really going to hear about the hard parts, the things that are really, really difficult for this mission. You're going to hear about the science in detail, in different ways, the breadth of science that's possible with this mission, first for heliophysics, but also possibly for other science divisions within the Science Mission Directorate. And that's really exciting to me because I see the storytelling and the exploration side of this really coming to life as we add to the possibilities that this mission brings to bear. And I want to take a minute to talk about what our study is called and what that means. So we are studying a pragmatic interstellar probe. And I want to define two of those terms for everybody. Pragmatic means that we are going to rely in all ways on not the technologies that might come to be in the next 10 or 20 or more years, but the technology that we know we have now and technologies that we know can be launched and be in line with the upcoming Space and Solar Physics Decadal Survey and its host of missions. And some very specific parameters are defined, and Jim will cover that in the engineering talk. Interstellar does not mean we're trying to reach another star. Interstellar means that we will quickly traverse from where we are here at the Earth. The spacecraft will get to the edge of the solar system and through the heliopause and out into interstellar space in a time frame that is useful from a science and a planning perspective from where we are today. So pragmatic means that we believe that this mission and the parameters that we've set for it allow us to execute this mission in a reasonable time frame. And interstellar means that the goal, the ultimate goal, the highest goal here is to reach interstellar space with an instrument suite that can really tell us what's going on out there. Now, so throughout this workshop, you're not going to just hear from experienced folks like Jim and Ralph and Pontus, but the other members of the team, they are actively working on missions like New Horizons, Parker Solar Probe, and more. And so when we say pragmatic, we're taking what we know about what can be done now and what we expect will be available in the coming decade to achieve that launch. So as we go forward through the week, you'll see that some real strong themes have emerged over the last year. Key challenges such as power and launch for this mission. And we're really pleased that at the end of this week, you'll be able to hear directly from June Zakrajsek, the head of the Radioisotope Power System Office. She's going to tell us where they are with the plutonium-based power systems that NASA provides for missions such as these. you'll also hear directly from the SLS team. As you'll see in the engineering presentation, SLS is the launch vehicle that we've baselined for this mission. And Rob Stoke, one of the lead payload accommodation engineers for the SLS team, who's been working closely with us for years now, and John Blevins, the chief systems engineer for SLS, are going to tell you about where SLS is and their perspective on this mission, as well as perhaps other science missions that could be supported with SLS. But these themes also include communications and operations over such a long distance. We can't send signals any faster than the speed of light, and pointing our antennas back from the spacecraft to the Earth is a real challenge from so far away. You're going to hear about longevity. This is probably the theme that has most strongly emerged to rear its head as a dominant and important thing for us to tackle now. But I'm not just talking about the hardware that's going to get sent into space. Yes, that has to last. Reliability of the electronics and the rest of the satellite spacecraft are key to success of this mission. But we're also talking about hardware on the ground. Are the communication systems and the computers that we expect to use over the many decades of this mission. The ground hardware is also an important longevity piece. But also, and this is where you come in, longevity of the people as well. We know that a mission of this length, of this duration, deserves and demands a team that can train its next generation of leaders decade after decade in order to grow the community and to keep the team healthy and strong. So these are the themes that you're going to see emerging as the longevity section comes and goes, and it just interlaces itself throughout the entire discussion of the program. And so that's one quick note on longevity there. That doesn't just apply to the team, the hardware, but it also applies to each one of you. I have found that I'm actually standing up right now as I give my opening remarks here. I hope that as the breaks throughout the week come and go, that you take time to get up and move however you can, however you want to. If you want to have your own private dance party, go for it. We don't have any theme music for the program yet, but that may be coming soon. If we've learned anything over the last 8 months, it's that taking care of ourselves is just as important as taking care of our work and taking care of each other. And so I hope that over the course of the week, you find time to get up and move as we take our breaks. Finally, building this team, building this program, and thinking about this over the long term requires, I believe, a profound respect for the other individuals on the team. And we, as a team, are following NASA's lead and the stance that they've taken over the last few years, supporting diversity, which includes respect for the individual, and it's a reminder to all of our community members to make space in the discussion for new voices. Diversity comes in many forms. New voices, dissenting voices. These are important things to include in community and to think about and to make space for others to speak. And on that note, I want to remind everybody that we have many students joining us, and I hope that you can connect with them, the professionals that are joining us today. We have 99 participants on board right now, and I think that about 40% of them are students. If all of the students from the 9 o'clock session rolled over into this session, and we had 290 people sign up. And so over the course of the week, as their topic areas come and go, please take advantage of the networking sessions that we've created to connect with the folks that are here, and not just speak your mind, though we're asking you to speak your mind and to tell us what you're thinking, but take time to listen. So this mission is not for me, it's not for you, it's for all of us. And it's really exciting to be taking these first steps with all of you right now. It's not been funded by NASA yet. We have ideas about a spacecraft, but there isn't a machine yet that we can point to and say, this will be the Interstellar probe. There isn't a launch date on anybody's calendar yet, though maybe Ralph has set one, I'm not sure. But if we, in 10 years, look back, or in 15 years after the spacecraft is in flight, you will see today as steps along the road towards this mission, which I believe could be a hallmark of our generation and future generations as we take these first steps out deliberately into the interstellar medium. So, in the spirit of two things: one, staying on time and on track with our schedule, we will let Ralph McNutt begin his talk at 10:30 and not sooner. With 7 minutes here left before 10:30, I'd like to take any Q&A questions that you might have from me. Though I expect that if there are open questions about the project, the study, or the team, or what comes next, that you're going to learn a lot about those things from Ralph's talk and Jim's talk and on throughout the week from everybody else. But if you have questions about logistics or anything, this is a good time to ask them, and so please do so. And I'll only take questions for about 3 or 4 minutes so that I can honor what I started with, which was take time to stand up and stretch and take a break in between each of the sessions. So I see Alan Stern has asked, what is the Interstellar Probe budget cap guidance NASA has given or APL has set for itself? Actually, I'll take a very short answer to that, and we will talk about this as time goes on, because we are working on a budget estimate for the mission right now, and that'll be coming out in the coming months. But we are trying to model this mission after Parker Solar Probe in terms of its financial scope. And so we see the total budget for Parker Solar Probe, and we think that we need to craft a mission that fits that same model, adjusted for inflation. Phase E is a challenge because it's so many years. We're not even quite sure how to account for that at this point in time. And so I don't remember offhand. Ralph, do you want to? Do you know exactly what the reported number is for Parker's full budget?
Well, I think, I'm trying to remember. If you look back at the confirmation documents, I think it was about $1.5 billion. I don't remember. I think that was real year dollars. Jim Kennison may remember better than I. That did include that did include the launch vehicle. That was the Delta IV Heavy. I think that was about. Oh, I don't remember how much it was. It was a few $100 million.
Yeah, roughly 350 million.
350. So anyway, Michael's right. Going out and proposing something that is going to cost $40 billion is probably not a good idea because it will be dead on arrival. And again, in terms of being pragmatic about all of this, the other piece one has to watch very carefully is the budget. Michael's right. I mean, one of the interesting challenges is to try to figure out how to deal with Phase E. I mean, we're advertising something that will last for 50 years. Voyager's been up there for over 43, but of course it wasn't forward funded for 43 years. There have been a number of mission extensions. We do extended missions for everything. We don't do 50-year mission funding by design up front in the same way that we don't design missions to last for 50 years up front. And the 50 years was sort of a stretch goal, but a reasonable one given the other parameters, and we'll go into a little bit of that. But suffice it to say, I think we're doing a good job, I think, of at least identifying everything that we need to be watching, and we're going to try to have all the analysis done in a timely fashion to back all of that up. And I think our first budget iteration we should have as a Christmas present within the group, and we'll see where we're going with all of this. But it's just like doing any of these decadal mission studies. It's like doing a proposal. You've got to start somewhere, and the first set of numbers you get you may not like, and then you need to do some thinking. And so that's one of the reasons that, just to emphasize that, is again what Michael was saying, this really is a two-way street. We're not just here to be preaching to all of you. We want to get input. It's very important. I think everybody understands from the last couple of decadal exercises that money does count. And so one has to have a variety of options to be thinking about. You need to be able to downscope as well as upscope. And I'll let it go at that. I'll be talking about a little bit of that in the next couple of minutes or so.
Thanks, Ralph. And Ron Turner, I see you asked a question as well. Thank you. It's good to see you here. He asked about doing breakout sessions. So today's sessions are in this Zoom webinar format, and there won't be breakout rooms specifically. They're all plenary sessions, if you will, where Q&A can happen just as we've been doing. During the later part of the week, we'll be not in Zoom webinar sessions, but in Zoom meetings, where the full functionality of Zoom will be available, including breakout rooms for people to talk about and respond to and discuss all of the work that we've been doing and what you're going to learn about. As Ralph said, this is really a two-way street. The cost discussion is one of the many things we want to have this week. For example, when Jim and the engineering team are talking about some of the detailed engineering stuff over the next few days, a good part of the time is set aside for them to share with you what they've done, but a great deal of time is set aside for you all to discuss that as well and to share your ideas. So we're at 10:29. Let's take a 1-minute break. If you want to, stand up or do your at-desk yoga or whatever it is that keeps the blood flowing for you. And we'll get going with Ralph's presentation in just a minute. Thank you all again for being here. This is really exciting.